All right, 4.3, modeling with quadratics. We're going to talk about domain and range a little bit more. I know I briefly spoke about it, but you're going to have a couple problems with domain and range, and we're going to be working with those problems. So I literally just pulled up the homework problems from Delta Math, and we'll talk these through. We're going to jump back and forth using our technology. So it says use graphing technology to find the range. Well, remember, the range of a function is all the y values. So we need to look at what y values are graphed in this parabola. So I have the equation here, f of x equals negative x squared plus 2x plus 2. I'm going to show you on Desmos. I believe they show you using the graphing calculator. So if you have a graphing calculator and want to watch their video, that's fine. It'll show you the same thing. So again, when we enter this in there, we put y equals negative, and again, just make sure that you enter the values correctly. X squared plus 2x plus 2. So negative x squared plus 2x plus 2 is the graph. And the y value then, looking at the max, is 3. Now, which way does this graph goes? It goes down. So it's everything from negative infinity to 3. So if we go to here, we go back to this problem that we were doing, okay, it's going to have you type in one of these boxes. Well, again, we would use this box right here because negative infinity is never included. So it'd be negative infinity, and then it ends at the y value, which is 3. So it ends at the y value, which is 3, and that would have a bracket around it. Okay, and that's the answer you would put in there for the range. Okay, looking at the next problem. Okay, use graphing technology to find the range of this function. The range, again, is the y value. So again, go back to Desmos, okay, and we have y equals, and this one was, I believe, a positive x squared plus 6x. Make sure you type it in correctly, plus 9. So if you look at this parabola, again, you click on the vertex there. Where does the y value start? Well, this one starts at 0 and then goes up. So when I go to that problem, this one, I would choose the bracket and then the parentheses because I'm going to start at the number, the y value of the vertex, which is 0, and it ends at positive infinity, which is this button right there. If it's negative infinity, you just hit a negative and then click this button. Okay, so that's the domain and range. The domain is always domain. So if it asks you to find the domain of this problem right here, so if this said find the domain, it would always be negative infinity to positive infinity. Okay, let's go ahead and take a look at the next problem. So now we're going to get into some word problems. Again, make sure you read these. There's, I believe, 5 or 6 word problems I'm going to have you do, and they all deal with the maximum and minimum. The nice thing is it's all done with technology. Think about what a parabola does. A parabola either has a lowest point or a highest point. Okay, so this says a company sells widgets. The amount of profit Y made by the company is related to the selling price of each widget X by the given equation. Use this equation to find what price the widget should be sold for to the nearest cent for the company to make the maximum profit. So this problem right here, make sure you pay attention. Find out what the price they're asking for. The price per widget is the X value. So again, I would plug this into Desmos. Okay, so go to Desmos, plug this in, Y equals, and you're going to have a large number here. So when I plug this in, make sure that I get this problem right. Negative 14x squared. Okay, negative 14x squared then it's plus 1035x plus 1035x. and then it is a minus 10266. 10266 minus 10266. So you're given a problem that looks like this. Again, to make sure that I type that in correct. 10266, and all my signs are right. So look, when you go to Desmos, you can't even see anything. Well, for this, you've got to really zoom out. So it almost looks like two straight lines up and down. You zoom way the heck out, okay? And then you're going to move up. So you're going to drag down and be able to move up. So I want to be able, it almost looks like a line, but if I zoom in, here you can see the top of this parabola. The more you zoom in, the more it starts looking like a parabola. Okay, so I go to this button right there, and again, remember what your X value and what your Y value stand for. This is the price per widget. This would be the maximum profit. So for this problem right here, the price per widget would be $36.96. So we would want to sell that widget at $36. Okay, so it would be $36, and I believe it was, 96 cents. That's all. That's all you do for this. You find the maximum, okay, 96 cents. So that's it. Now, if it asks for what would the maximum profit be, then we would write the Y value down. And there's some problems that ask for the Y value, so make sure you pay attention to what they're asking for. This next equation is going to be the same exact type of problem. Okay, so this one says a rocket is launched from a tower. The height of a rocket, y, so y is the height, in feet is related to time after the launch in x seconds. Use this equation to find the time at which the rocket will reach its max to the nearest hundredth of a second. So we do the same thing. We want to plug this in to Desmos here. Okay, so we want to go to y equals, and I believe that was negative 16x squared. And plus 235x plus, I believe it was 133. We're just going to double check it. So plus 133. Good. So go to Delta Math. Now look, or I'm sorry, go back to Desmos. You're not going to see anything. When I don't see anything, I'm way up here at 8,900 for my, so I hit this home button. It'll take me back to my normal screen. And again, we got to zoom out to when I can see this. And then I'm going to start going up to where the top of this rocket launched would be. So I'm trying to find the maximum height and how long it took to get to that maximum height of this parabola. Okay, so it's a little bit tedious, but trust me, the technology definitely helps us rather than doing this freehand. If I made you do this freehand, we would do what we did yesterday, and it'd be negative b over 2 times a. So right here, and it says to the nearest second, okay, this is the maximum height. This right here is how long it took the rocket to get up there. So it says to the nearest hundredth of a second, so it'd be 7.344. Okay, so it'd be 7.344. So it would take 7.3. Oh, that is not what I just said. 7.34 seconds to the nearest hundredth. Okay, 7.34 seconds to get to its maximum height. And what would that maximum height be? That maximum height would be 995 feet. Okay, so I wanted to look at one last problem. We did something like this with linear regression. Well, now we're going to do quadratic regression. Okay, so if you look at, you're going to have a problem that looks like this. Okay, and I just want to go over one with you and kind of refresh your memory on how to do this. Not worry about reading the problem right now. Okay, company X tried selling widgets at various prices, see how much profit. You have to make sure you pay attention what they're asking you to do and what to round to. Write a quadratic regression equation for this set of data rounding all coefficients to the nearest tenth. You have to round correctly. Okay, so when we write this equation down, we have to make sure that you round to the nearest tenth. So again, going through this, we're going to copy the values for the calculator. Okay, we're going to open my stats calculator. I'm going to paste the values. So that literally does all the work there for you. Then I'm going to go to Calc menu, go to the sub menu, And we now want a quadratic regression. We're going to calculate it. And the A, B, and C are exactly that. They are my A is the number in front of the x squared. So they wanted the nearest tenth, so it would be negative 12.9x squared, okay, plus 629.2x, and my C is minus 4,656.5. So this would be the equation that I would go back and plug into right here, my regression equation. Y equals negative 12.9x squared. Okay. Plus 629.2x minus 4656.5. Okay. And then it's asking you to answer the question. Well, what are they asking? Using this equation, find the profit to the nearest dollar for a selling price of 36.5. So for this problem, they're asking you to plug in 36.5. Okay, so y equals negative 12.9 parentheses 36.5 squared plus 629.2 times 36.5 minus 4656.5. So I would go back, I'd plug that into Desmos just like this. Okay, I would just put negative 12.9. Make sure you're entering all of this stuff correctly. Again, it told me to plug in 36.5. I'm going to square it. Okay, plus 629.2 times 36.5. Close the parentheses, and then we're going to subtract 4656.5. Okay, so I would get y equals $1,123.28. I'm not sure what it tells me to round to. It told me to find the profit for selling price, round to the nearest dollar. So for that selling price, we would round to the nearest dollar. It would be $1,123. And $23. So again, as we go through that, make sure that makes sense as you're doing this. And again, if you look at this, this makes a quadratic equation. So look, as the price goes up, it's not going to keep going. It's not linear. So here you can see the profits going up, up, up. Once it gets to 29,000, it starts going down again because that's the other side of the parabola. So this should make sense when I put in 1, 1, 2, 3, that it's smaller than the actual max. Okay, so let's take a look at why this is incorrect. Did we round wrong? Did I round wrong? Oh, I didn't put a Y. Okay, so again, here's where Delta Math is silly. Everything here is correct. This would be one of those problems that we do on a quiz that you would say, Mr. Lipinski, give me my points back. Okay, because we just didn't put Y equals. We did all the math correct. So make sure that you pay attention to those little details. There's one problem like that I would like you to do and be able to use this calculator on the Delta Math program.